Okay, 9.3 is the converse of the Pythagorean theorem. Now the nice thing about the converse of the Pythagorean theorem is it's actually the same thing as the Pythagorean theorem, except in the Pythagorean theorem, we know it's a right triangle, and we're trying to figure out a third side, correct?
Yep.
Okay. With the converse of the Pythagorean theorem, we're going to know all three sides, and we're going to figure out if it's a right triangle. Okay, so maybe it's not always a right triangle. I'm not going to have you write that theorem down because it's the same thing as the Pythagorean theorem, which is what? Good. A squared plus b squared equals c squared. Okay, the difference is now you know all three sides. We have to figure out if it works. Okay, so you might have a triangle, and I'm going to do different examples than what you have in your book. You might have a triangle that looks like this. 10, 7, and 13.4. And so that happens to be a decimal, not a big deal though. I want to know, is this a right triangle? If it is, then a squared plus b squared should equal c squared, right? Okay, now the only other catch to this is, how do I know which one is C? Because there's no right angle to figure out my hypotenuse. Taylor? The biggest angle? I see what you're thinking. What if they did this, though? Now you don't have angle. What if they didn't show you this? They just gave you three numbers. I think you're going to do it right. I just don't think you're using the right words. But I think you know what you're talking about. Right. So we have to use the longest side as our hypotenuse, right? That's what you're saying? Okay. Okay. So always find your longest side, and that's always your C, correct? Okay. So then I would have 10 squared plus 7 squared, which doesn't matter what order I write those in. No, equals 13.4 squared. Or I think Taylor would write it the other way around, right? But it doesn't matter. Okay, it's the same thing. Your book actually does write it the other way around, which is probably where you got that from. Maybe? Okay. Well, it doesn't matter. Either, however you want to do it. 10 squared, 100 plus, so I have 149 on this side, equals, what is that? 179.56. So my question is that a right triangle? No, because 149 doesn't equal 179.56, does it? Okay, so no, this is not a right triangle. Okay, the nice thing about what we're doing today is, did we have to subtract anything to the other side? No. All we have to do is simplify the left side, simplify the right side, and if they're equal, then it's a right triangle. If they're not equal, then it's not a right triangle. Pretty straightforward, right? Because we know that Pythagorean theorem would have to work if it was a right triangle. You ever agree with that? Okay. So let's do another one here. This one is very similar, or uses, not similar, but it does use the information that you guys worked on your review on Thursday. Okay, we want to know, is that one a right triangle? Okay, now again, here looking, you can probably tell which one is your hypotenuse, right? Or your C. What if they just gave you a list of numbers and didn't give you the diagram? How would you find out which one is your longest side? I would strongly disapprove of that, I guess. I would not say guess. That would be a bad decision. I would type this in my calculator. Figure out what the heck that is. Well, what is that? 13.4. So now you know which one's longer, right? 6 square roots of 5 is the longest side, right? Okay, so even if they didn't give you this diagram, you should be able to figure that out. So how am I going to set this up then, Taylor Hart?
6 squared plus 1 squared plus 6 squared is 5
Square, good. Okay, and then if this is a right triangle, the left side's going to equal the right side, correct? Okay, well 6 squared is 36 plus 144 equals, now this is what we talked about on Thursday. How do I do this? How'd you get 36? Okay, 6 times 6, so you squared there, right? So you got 36 times, Taylor Stokes is telling me, times 5. 5, because then I took the square root of 5 and squared it also, right? Okay, why times? Because I had some people last class period telling me it should be plus. Right, there's no sign in between those, is there? So that if there's no sign, then we know it means multiplication, multiply. Okay, so keep that in mind. There's no plus sign in there, so you're not adding anything. Okay, but there is a multiplication sign that's not seen, so you need to multiply these two. So now I have 36 plus 144 is 180 equals 180. So Jacob, is this a right triangle? Yes, it is. Okay, again, the nice thing about this is everything on the left side just stays over there, doesn't it? Everything on the right side just stays over there. You just have to reduce and simplify. I personally think it's easier than solving for a third side. You'd agree with that? With us, Travis? Good? Okay. There's just less to do. Alright. Now the only other two things that are going to make this lesson a smidge more challenging are two new theorems that we have. The first one we're going to call acute triangle. It doesn't actually have a name, but we're going to call it acute triangle. Okay. I'm going to shorten this up quite a bit, and I'm actually going to write it a little bit differently than what they have. They, again, have the C on the left. I'm going to put the C on the right because I like my letters A, B, C. I like to have everything in alphabetical order. So this says that if A squared plus B squared is greater than C squared, then the triangle is acute. If A squared plus B squared is greater than C squared, then the triangle is acute. Isn't that the same thing as saying C squared is less? You guys agree with that? C squared is less. So if your C squared is a smaller number than your A plus B squared, then it must be an acute triangle, right? Okay. The one that goes with that is another theorem called obtuse triangle, which is going to say basically the same thing, except that sign is going to flip. If A squared plus B squared is less than C squared, then the triangle is obtuse. Okay. Also, another way to think about this is that C squared is what? Bigger. Yep, C squared is bigger, then it's obtuse. If C squared is less, then it's acute. Okay, so looking back up to this one up here that we said was not a right triangle, C squared is bigger, right? So is this acute or obtuse? Obtuse. Okay, so it's not a right triangle, but it would be an obtuse triangle. Okay, ready for 2 examples on that one? Okay. On that one, they give me 3 numbers. They give me 8, 18, and 24. Their directions say, decide whether the set of numbers can represent the side lengths of a triangle. If they can, classify the triangle as right, acute, or obtuse. So what's the first thing you got to decide? Is it a triangle? Can they make a triangle? Does anybody remember how to do that? Because it's been a while. Carly? Okay, so any 2 sides have to add to be greater than the third, right? Okay, so Carly says 8 and 18 have to be bigger than 24, while 8 and 18 is 26, so we're good there. 18 and 24 is 42, which has to be bigger than 8, obviously, because they're both bigger than 8. And then 24 and 8 is 32, which obviously is bigger than 18 as well, right? Okay, so we're good. It's definitely a triangle, so that's my first answer. Yes, it's a triangle. Now we want to know what kind. Okay, well, we know to figure out what kind, I'm going to do what? I'm just going to put it into the Pythagorean Theorem. I know if it satisfies the Pythagorean Theorem, it is a right triangle. If my C is smaller, it is acute, and if my C is larger, it is obtuse. Good. So I have 8 squared plus 18 squared equals 24 squared. How did I know to put them in that order? 24 is the biggest one. Okay, keep in mind, it might not always be the last number, right? Okay, so just keep that in mind. Your biggest number has to be by itself. That's your C. 8 squared is plus 324 equals 576. 324 plus 64 is 388. So, is it a right triangle? No. Royal, what kind of triangle is that? That is obtuse. Good. Because my C is larger than my A plus B. So it is obtuse. Okay. We'll do one more of those. .2, 4.8, 5.1. Okay, so step 1 is to figure out what? Is it a triangle? Well, 3 plus 4 is 7, so without your decimals, you're already bigger. 4 plus 5 is, so without your decimals, you're still bigger. And 5 and 3 is 8, and without your decimals, you're still bigger. Okay? So, which one of these, Laney, is my C, or my hypotenuse? 5.1. Why? Because it's the biggest. Good. So I have 3.2 squared plus 4.8 squared equals 5.1 squared. Does it matter what order I put these 2 in? No, I could have switched those 2. That's the important one. Okay, anybody got a calculator? Run these through for me. 10.24. 23.04 equals 26.01. Thank you. Add them. So I get 8, 2, 3, 3. 33.28 equals 26.01. Okay, so my first answer was yes, it's a triangle. Okay, Paige, obtuse or acute? It's acute because my C is smaller, right? Okay, so this is acute. Okay. You guys agree with me when I say it's not bad? Okay? You're just sticking to your Pythagorean theorem. You're probably going to use Pythagorean theorem on every single problem, right? Because it doesn't matter what process we're doing. That's what we're using to figure out if it's a right, acute, or obtuse triangle. Alright. Your assignment for tomorrow, and a handful of people have got this finished. So hopefully you can get at least close. Quickly, please. Alright. There's your assignment for tomorrow. Also, we will have a quiz 2 class periods from now. Okay?